Hello, dear students. Today, myself, Suresh Halbandgi from Satish Pradhan Gyan Sadhana College, Thane, would like to explain the phenomenon of uniform circular motion, wave motion, and oscillatory motion, and how these phenomena are analogous to each other with the help of the animation. Okay, these are the basic physics animations. Now here, if you look at this animation, we observe that there are mainly three particles. One particle is on the circumference of the circle and it will be performing circular motion, uniform circle. The another particle is the projection of this on the diameter of the circle. The particle moving along the diameter of the circle, this will act as the oscillatory motion. And there is a third particle which will be performing the wave motion. Okay, now I will reset this to the original position and I start the animation. Okay, now here, now it is at this point, the particle performing circular motion is at this point. Same particle, another particle, it will move along the circumference of the circle, and the particle performing wave motion is at this position. Okay, so performing UCM, it is here. Performing wave motion, it is here, right? And the third one, which is moving along the diameter of the circle, that will be the third one. Okay, now just observe this phenomenon carefully, right? I'll start this animation. So when the particle performing circular motion, it completes one revolution. At that time, particle performing wave motion completes one oscillation. You see, it will start from here, it will move in this way, and again it will come to the mean position. It will complete one wave. So we observe one revolution, right? One revolution is equivalent, one revolution is equivalent to one wave. And at the same time, the projection of the particle in UCM, that will constitute the oscillatory motion. So third particle is performing oscillatory motion. These three types of motion, these are not same, but these are analogous. So particle performing oscillatory motion, it completes one oscillation. At that time, particle performing uniform circular motion completes one revolution. At that time, particle performing wave motion completes one. Similarly, we have the expressions for time period. Time required for completing one oscillation is called time period in oscillatory motion. Time required to complete one revolution in uniform circular motion is the time period of UCM. Time required to complete one wave is called as a time period of wave motion. So in this way, we can have similar definitions. Now, we shall see how are the positions of the particles. Okay. Now, in this animation, it is, I will tick on the position and see the positions in the three different wave motions. Okay, now I'll stop this. I'll click on the velocity. Now, in UCM, the velocity of the particle is a tangential to the circular path. We can observe this. Okay, this is the direction of velocity in the UCL, which is always tangential to the cell. I'll start the animation and you just have a look at it. Beautiful analogy. Here, the tangential velocity can be resolved into two perpendicular components, and it is shown. Okay, one is a horizontal component and it is a vertical component. Now we shall have clicked it on the acceleration component. In UCM, the direction of acceleration is along the radius toward the center. Okay, similarly, we can have the displacement, velocity, and acceleration in the case of wave motion also in oscillator. So in this way, we can have the analogy. Basically, in the 11th or 12th standard, we learn the motion separately. But in actual life, when the events are taking place, it may be the combination of two or more motions at a time. For example, there is a sewing needle. Okay, it is actually the oscillatory motion. It can be related to the some other motion in the daily life. There is a flooring floor. In fact, floor mill is there. We grind. There is a grinder and there is a belt attached to that. Belt performs circular motion, and the grinding machine performs rotational motion. So it is a combination of rotational motion and circular motion. So in this way, we can have number of examples which can be the combination of two or more. I hope you might have liked this animation. In the coming future, I will try to explain the different concepts in the physics with the help of physics. For today, we'll stop here. Thank you so much.